I did not create this video for the user of Multism on how to design, develop and simulate conventional and emerging multi-level inverter topologies. Do not forget to click on the subscribe button below for more videos on this topic.
To start with, this is one of my projects. It is a modified cascaded H-bridge multi-level inverter topology. This topology consists of 3 cells. Each cell is capable of generating 5 switching states. 2 cells in cascade generate 25 switching states, and 3 cells in cascade generate 125 switching states. For this particular design, not all the 125 switching states are being used. Only 33 of the 125 switching states are used to generate 33 voltage level, and the remaining switching states are for the purpose of reliability. This design consists of 15 switches, 12 signal voltage sources, and 6 DC voltage sources. This transistor diode conducts currents in 2 directions and blocks currents in 1 direction. This transistor, nested in a diode H-bridge, conducts currents in 2 directions and blocks currents in 2 directions. To place a switch, click on the Place Power Component icon. Then scroll to Switches, then scroll to Diode, click OK, and click again to place it. Then scroll to Transistor, click OK, then click again to place it. Then scroll to Transistor Diode, click OK, then click again to place it. Now double click on each of the switch to fill the field value. As you can see on the screen, that these are the default field value, which you can change to suit your need depending on the power loss analysis. But for this particular project, all the switches have the same field value. The transistors have the same on voltage. Now, to place a source, click on the Place Source icon. Then scroll to Power Sources. Then scroll to DC Source. Click OK. Then click again to place it. Then you scroll to Signal Voltage Source. For this project, the piecewise linear voltage is used. Click OK and click again to place it. Double click on the DC voltage source and enter the required DC value you want it to generate. And also, you double click on the piecewise linear voltage generator. For this, there are data points to be entered. So the next video, I'm going to explain how to use a piecewise linear voltage generator to generate any signal that you want for your project. And for this project, if you want to replicate it, you need to send a request to the email at the right hand corner of the screen. As you can see, that for PG6, that is the 4 signal voltage source, these are the data point being entered. So, and for the second one, PG15, you can see a long list of data points being entered. So all of the signal voltage sources have particular signal voltage that they generate in order for this topology to generate 33 voltage levels. When you are done designing this topology to simulate the output voltage magnitude and frequency, we connect a multimeter and a frequency counter to the output. Now double click on the multimeter. As you can see that the default measurement is DC. Now change it to AC. Now also double click on the frequency counter and click on the green button to simulate. Now the output voltage is approximately 219 volt and the frequency of the voltage waveform is 50 Hz. Now we can also simulate the period of the waveform. Now the period of the waveform is 20 milliseconds. To simulate the transient voltage and current waveforms of the RL load connected to the output of the topology, connect a voltage probe to the output and a current probe in series with the load. Then click on Simulate, Analysis and Simulation and go to Transient. Now the start time is 0 because we are observing the nature of the wave from the origin over a cycle, and the end time is 0.00 because the frequency of the wave is 50 Hz. Now click on Run to simulate. As you can see, the green graph is the voltage waveform. It consists of 33 voltage levels, and the red graph is the current waveform. We can also change the parameter of the load. Now let's change the resistance of the load to 1 ohm and the inductor to 1 millihenry. Then click on the Run button to simulate. So as you can see that the current of the load has increased and the voltage of the load remains the same. So the voltage and the current waveform are out of phase, which is the characteristics of an RL load. To simulate the Fourier and total harmonic distortion of the output voltage waveform of this topology, connect a voltage probe to the output, then click on interactive simulation to change the simulation mode to Fourier, then change the fundamental frequency to 50 Hz, which is the frequency of the voltage waveform, and the number of harmonics to 200 because 2 is not sufficient to give us accurate total harmonic distortion. And now to the result. The results will be displayed in both chart and graph, and for it to be displayed in chart only or graph only, you choose either chart and graph depending on how you want your result to be displayed. But for this simulation, I want it to be displayed in both chart and graph. Then click on Run to simulate. So as you can see, the table above shows the result of the total harmonic distortion, which is approximately 3.5%, and also the harmonics and their corresponding voltage magnitudes. So and below we have the graph that shows the voltage magnitude of the harmonics and their frequency. To simulate the signal voltage waveforms controlling the switches, connect a voltage probe, for example, to the input of the piecewise linear generator controlling switch S1. Then click on interactive simulation to change the simulation mode to transient. So we want to simulate the signal voltage waveform for a period of 0.02 seconds. Then we click on run to simulate. This is the signal voltage waveform controlling switch S1. We can also simulate the signal voltage waveform controlling switch S2. Click on the run button to simulate. So the signal voltage waveform controlling switch S2 consists of series of pulses, and also let us simulate the signal voltage waveform controlling switch S3. Click on the run button to simulate. So likewise, we can see that the signal voltage waveform controlling switch S3 also consists of series of pulses. To simulate the output voltage waveform of each cell, connect a differential voltage probe to the terminals, for example, the output terminals of cell 3. Then click on the run button to simulate. This is the voltage waveform of cell 3. It consists of 5 voltage levels. Now let's simulate the output voltage waveform of cell 2. Oh, as you can see, the output voltage waveform of cell 2 is of high frequency. Now let's simulate the superposition of the output voltage waveform of both cell 2 and cell 3. Nice. The superposition of the output voltage waveform of cell 2 and 3 forms a multi-level voltage of almost 12 levels. To simulate the power input waveform of the DC sources and the power waveform of the RL load, connect the power measuring probe on the load resistance and on the DC source, for example V1. Then click on the run button to simulate. So as you can see, the red graph is the power waveform of the RL load, and the green graph is the input power waveform of the DC source V1. Now this is the end of my video. So if you like this video, of using NI MULTISM to simulate different topology of multi-level inverter, do not forget to click on the subscription button below, and if you have more questions pertaining to simulation, you can forward your message to the email that is on the right hand corner of the screen.